So in this example, we're given that f of x equals 3x to the fourth minus 4x cubed plus x squared plus 6x minus 2. We want to find the rational zeros and then the other zeros. That is, we want to solve f of x equals 0, and then we want to factor f of x into linear factors. Okay? So first of all, we know that we should have a total of 4 zeros because this is a fourth degree polynomial function. And so by the rational zeros theorem, we know that we have a limit on what the possible rational zeros could be. Okay? So if we have p over q, if that is going to be a 0, then p has to be a factor of the constant, negative 2, and q has to be a factor of the leading coefficient, 3. Okay? So the possible values of p are the factors of negative 2, and the only thing that negative 2 can be divided evenly by are plus or minus 1 and plus or minus 2. The possible values of q have to be factors of 3, and so the only possibilities there are plus or minus 1 and plus or minus 3. So the possible values of p over q is going to be these possibilities. So it could be plus or minus 1 over plus or minus 1, which would be plus or minus 1. It could be plus or minus 2 over plus or minus 1, which would be plus or minus 2. It could be plus or minus 1 over plus or minus 3, which would be plus or minus 1/3. Or it could be plus or minus 2 over plus or minus 3, which would be plus or minus 2/3. Okay? So there are 2, 4, 6, 8 possibilities for rational zeros. Now there could be other non-rational zeros. There could be, for example, irrational zeros, or there could be imaginary zeros. But if there are rational zeros, these are the only 8 possibilities. And so we want to figure out if any of these 8 possibilities are, in fact, zeros of our polynomial function. So we're going to find the rational zeros first, and then we're going to find any other zeros. Okay? So rather than just guess, I'm going to show you sort of a shortcut that we can use to kind of to improve our ability of being able to determine what the rational zeros are. And that is by using our graphing calculators. So I have entered our function into my calculator, and I'm going to do zoom 6 and take a look at the graph of this. Okay? And so if you take a look at this, it looks like this graph is crossing at -1, and it also looks like maybe that graph is crossing, well, it's definitely crossing somewhere between 0 and 1. So if we look at that a little more closely, it looks like maybe it's crossing possibly at this 1/3 value right here. So if I have rational zeros, it looks like it's going to probably be -1 and 1/3. So those are going to be the ones that I'm going to check to see if they're rational zeros. Okay? So I'm going to use synthetic division. I'm going to write down my coefficients, 3, -4, 1, 6, and -2, and I'm going to check to see is -1 a 0. So if I drop down 3, -1 times 3 is -3. -4 plus -3 is -7. -1 times -7 is 7. 1 plus 7 is 8. -1 times 8 is -8. 6 plus -8 is -2. -1 times -2 is +2. -2 plus 2 is 0. That is the remainder. So yes, -1 is in fact a 0. Now let's check to see if 1/3 is a 0 as well. So when I'm going to check that, I'm going to not start with my original function. I'm going to start with this factor of the function. So I'm going to write down the 3, the -7, the 8, and the -2. So what I'm getting at is our polynomial function, f of x equals 3x to the fourth minus 4x cubed plus x squared plus 6x minus 2, we've just discovered that that factors into x plus 1, because negative 1 is a 0, times the coefficients would be 3x cubed minus 7x squared plus 8x minus 2. And so if 1/3 is a 0 of my original function, it will also be a 0 of this function. So I'm going to divide this function by x minus 1/3, or I'm checking to see if 1/3 is a 0. Okay, so I'm going to drop down the 3. 1/3 times 3 is 1. Negative 7 plus 1 is negative 6. 1/3 times negative 6 is negative 2. 8 plus negative 2 is positive 6. 1/3 times 6 is positive 2. Negative 2 plus 2 is 0. I do get a remainder of 0. So yes, 1/3 is a 0 of this, which means it's also a 0 of our original function. Okay? So this factors into x plus 1, and now it's 1/3 is a 0, so that's going to be x minus 1/3. And then I'm left with 3x squared minus 6x plus 6. Now, if you look at this, the 3x squared minus 6x plus 6 has a common factor of 3 that I can factor out. So I'm going to do that. So I would have times 3 times, if I factor out that 3, that's going to be x squared minus 2x plus 2. And then maybe what I would do is multiply the x minus 1/3 times this 3. And so I would get 3x minus 1 when I multiply. That way I don't have the fraction. 3 times x would be 3x. 3 times 1/3 would be 1. And we have x squared minus 2x plus 2. Okay, so now I want to, I still need to find the other rational zeros, if there are any, and it doesn't appear that there are any. So I'm gonna use this last part to find the other zeros. Okay, now it would be nice if that factors, but it doesn't. So I'm going to have to use the quadratic formula to solve and figure out what the other two zeros are. So what I know so far is that my zeros are negative 1, 1/3, and I can solve, I can set this equal to 0 and solve to figure out what the other two zeros have to be. I'm going to do that on a separate sheet. So if I have x squared minus 2x plus 2 equals 0, using the quadratic formula, a is going to be 1, b is going to be negative 2, c is going to be positive 2. And so the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so substituting in, I'm going to have the negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 2, and that is all over 2 times 1. The negative of negative 2 is positive 2. And then underneath the square root here, we have negative 2 squared, which is 4. And we have minus 4 times 1 times 2, which is minus 8. So that's the square root of negative 4. 4 minus 8 is negative 4, and that's all over 2. Well, the square root of negative 4 is 2i. So I have 2 plus or minus 2i. And both 2 and 2i can be divided by 2. 2 divided by 2 is 1, plus or minus 2i divided by 2 is I. So what we really have there are two things, 1 plus I and 1 minus I. Those are our other two zeros. So bringing back in my original page, my other zeros are 1 plus I and 1 minus I. So I have the zeros, okay? And so now I can finish factoring. So I have x plus 1, 3x minus 1, and then this factors into x minus 1 plus I times x minus 1 minus I. And notice the parentheses. X minus the quantity 1 plus I and x minus the quantity 1 minus I. So here we have our 4 zeros. So this is the answer to part A. And then we have factored this into linear factors. Here's our answer to part B.